10 minutes to go through these. As a reminder, next week we will be only on Zoom because they're doing the Nutcracker in here. So today's gonna be a pretty problem-heavy day. So let's get started.
Oh shoot.
All right, let's get started on these. So this first one, pretty straightforward. We don't have much going on with our diene. Our diene file has these two ethyls being cis to each other. So we're going to end up with a syn product. They should both be, I'm going to draw them both as wedges, or sorry, dashes, to give us this product here. Our next one, we have two different groups. So this one, these are trans to each other. One of them is an ethyl, one of them is a methyl here. I'll draw on the cyclization. So as you remember, all these reactions make a 6-membered ring. With a double bond. In this case, they are starting as trans, so they need to be anti to each other. So I'm gonna draw one of them as a dash, one of them as a wedge, and then put a plus minus to indicate that it could be the other way. This marker's really dying. All right. Our next one, I put a carbonyl in there just to have something different as to one of these groups. They're still going to behave the same. Still going to make our 6-membered ring with a double bond. And there is really only one substituent here. I'm going to draw it in the down position. But also plus minus because it could also be in the up position. All right. So this next one leads to two products, and I'm actually going to kind of break these two out and explain why it leads to two products. Because this was a big question in the 930 class. So taking a look at the top one, or sorry, the one on the left here that we just did. I'm going to redraw this. And I'm actually going to make it a little more complicated. So let's do this here. This should lead to this product. So the big question was, why is there only one product? Why is there not two products? If I flip this over, because it is asymmetric, I can make this here. So this would go to something that looks like this. And the reason why there isn't two products is because, so the plus minus version, which I can draw out, that's going to be where we flip all our stereochemistry. So these both become wedges. If I take this here and I flip it over, just like picking it up like a pancake, flipping it upside down, it would become this. These dashes here, when they flip 90 degrees, is going to become these wedges. Someone asked in the chat, is there any stereochemistry on the double bonds? And no, it's just the carbon that is directly attached. So this is a wedge here. These are just regular double bonds. You can't have stereochemistry for a double bond. So the easy way to kind of identify this is that this is asymmetric, but this one here has a plane of symmetry. Because this has a plane of symmetry, you're only ever going to get one product. So let's take the next one, because that one is where this gets different. So if we take that bond off and draw out this instead, now these are both asymmetric. And as I told you in the instructions, this is going to lead to two products. So 6-member ring, double bond, methyl group here. We could have this, or if we flip this over, no, not that. This would be our other product. And compared to this one here, because we have two methyls, when we flip this over, there's still a methyl and a methyl here. For this one, if I try to flip it over and do the same comparison, so I'm going to draw out the other version of this. When I flip this guy over to put this carbonyl on the top and then our methyl on the bottom, it flips our entire molecule. So this methyl is now in the bottom. We picked this up, flipped it over. So these two will never line up if you try to superimpose them, because their methyl is up here versus being down here. So these are two different products. All right, so anytime you have both of your molecules being asymmetric, that's when it's going to lead to two products. Versus if you have a plane of symmetry, it's just going to give you one product. So let's get back to that first page, which I put over here. All right, this one. As we just said, can give you these two products. Oh, I didn't have methyl there, did I? Whoops. All right, well, I'll throw it in. All right, next one, we are starting to deal with these bicyclic compounds. As a review, anything in the middle is going to get kind of pushed upward. Things on the outside are going to get pushed downward when this comes in. We're going to end up drawing, I'm going to draw this in 3D. We'll have a double bond here. These two are cis to each other, so they're going to be syn to each other. I'm going to draw one of them down, both of them in the down position. For this 6-membered ring, going to be very similar, except our bridge head's going to be a little bigger. Burning through a lot of markers today. These are going to be trans to each other or anti to each other, so it give us this product here. All right, I'm going to be a little short on room for this next one. So I'm going to draw these on another page. Dealing with the triple bond. Going to have a little bit less stereochemistry, which is nice. These are both asymmetric. So they're going to lead to two different products. First product is going to be where this is just as drawn. So let's make our 6-membered ring. We're only interacting with one of the two double bonds. So we should still have another double bond on the other side. Methyl group here, drawing in ketone and methyl here. We could also flip this over. To give us our other product. As so, remember, these are sp2, so there's no stereochemistry, which makes these kind of nice. All right. Last one is a bicyclic triple bond one. Again, not going to have a lot of stereochemistry for this. Because we got double bonds on both sides. We'll have, I'm going to put the aldehyde on this one. Ketone on this one. Plus minus. All right, that is all of these. I'm going to go over some more complicated ones and just kind of give you guys a lot of examples. We're going to go through the rest of the Diels-Alder reaction today, which deals with something called endo and exo rules. Let's get started with this first one. Okay, so we talked about this a little bit on Wednesday. I put CH3s in the middle here. H is on the outside. When our cyclization happens, everything that's in the middle is going to get shoved upward. The two H's are going to get shoved downward. It's going to favor something that looks like this. So the reason why these two ethyl groups are pointing downward is going to have to do with the trajectory which this reaction occurs in. This is going to be referred to as the endo product, which also happens to be the major product. If I draw this out in 3 dimensions, there's 2 different options for what can happen. I can either have, I'll draw them both. I can either have it where these ethyls are pointing downward when they're coming in, which puts them out of the way. I think of this as being below. If I put these in the downward out of the way position, this is what's going to lead to this endo product. So if I think of them pointing down, they end up as dashes here. The other option is to have them come in with them kind of pointing upward. The issue with that is that there's a bunch of H's, which means there's going to be this big like electron cloud. It's going to kind of get in the way of things. And this is going to lead to our minor product. So the minor product would be where this comes in the other way. And then these would be wedges here. This is called the exo product. Endo. Exo. One way to think about these is that the diene portion of your molecule, that was everything on the left side of this dotted line, is going to stay the same. No matter what happens when you come in, what was in the middle is going to get pushed up, what was on the outside is going to push down. So this part here is going to be locked in. You can either have this up or this down, but this is all going to come from your dienophile. So this diene portion of it is going to be locked together. And when we start drawing these, once you have kind of your diene drawn out, you can draw all 4 of them immediately and not have to worry about it. So another example, I did this one in the other class. This is an example where it doesn't actually matter. But I talked about it with them, so I'll talk about it with you guys again. So if I have it where they're like nicely symmetrical, it's not going to matter because they are going to actually give me the exact same product either way. So this could go to I think this is just going to give us one product. Yeah. This here. So if you have a nice plane of symmetry on this one, you don't have to actually do an exo and endo. But I don't really want to focus on that. I'm going to talk about ones where we do care about it. So let's break these down a little bit. I'm going to give an example that's going to be pretty tough, and we're going to walk through all the different possibilities. These are both asymmetric. Which means there is going to be 4 products from this. So when our cyclization happens, we're going to make a 6-membered ring. That part doesn't change. This methyl group in the middle is going to get pushed up. the H's would get pushed down. We will make this here. I'm not going to draw in this ketone yet. I did not turn the mic off. Whoops. Okay. Instead, I'm just going to redraw this 4 times because we're going to end up using this exact same shell every time. Okay, so that is our diene portion of it with this part of the double bond here. So let's throw in our dienophile part. Our favored position is where this comes in from below. Which would give us this product. This would be an endo product. This large group here is on a dash. Our exo product would be where the carbonyl comes from above. Oh, yeah, there's gonna be a lot of plus lines. So these are 2 of our products here. We could also have this. So this is going to give us almost the same thing. We're just shifting it down a carbon. Carbonyl down here as a dash, carbonyl here as a wedge. Our same rules apply. This is an endo. Oops. This is an exo. Our exos, or sorry, our endos are going to be our major products because we want to favor this being out of the way. So this is one that if we're asked to draw the major product, it would be these 2. If you had to draw all 4 of them, that would be sorry about that. My little mic wind breaker fell off. All right. And if we're thinking about these, having this ketone here as a dash is going to be more favorable. It's out of the way when it comes in. Same thing with this one down here. Versus having it on a wedge would be less favorable. Bless you. I'm going to do one more of these, and then I'm going to talk about some resonance-based ones, which are different, somewhat simpler because you only get one product, but also more complicated. So let's say I have this. We have different, this is only going to lead to 2 different products. So this one's symmetrical, which is kind of nice. So there are really only 2 different ways I could draw this. The first one would be double bond. These guys are on the outside. So I'll draw them as dashes. These 2 are sp2. Doesn't matter. This is kind of our diene portion here. Let's draw it again. So we can either have the two ethyls on dashes and the methyl on a wedge, or the methyl on dashes, the two ethyls on wedges. If you have multiple groups, it's kind of just the bigger one trumps it. So really, you want your biggest group to be in the away position. So our endo for this is going to be where these big ethyl groups are dashes. The CH3 is on the wedge. Exo will be the opposite. And we've kind of always been doing this. If we think back to this here, technically there are two H's that are both on wedges in our final product. We only cared about this one because it's like the largest group. So when they're actual visible groups, like a methyl group, which isn't just like part of this shorthand, we want the larger groups to be the ones that are pointing away. All right, last concept in Diels-Alder is going to be resonance-based versions of these. I'm going to go over, I think, 3 of them. And then we'll do a couple more of those on the beginning of Monday's class. So I'm going to put an LME on here, and that is going to be an electron donating group. It's able to do resonance, as well as having a carbonyl here, which is also able to do resonance. So we've had carbonyls before. We haven't had both of these together. Let's just talk about the possibilities first. So using our normal deductive reasoning, we can draw 4 different possibilities for these. 6-membered ring, double bond. This OMe is outside of our diene. It's not in the middle like these two H's are. So I'm going to draw this on a dash. And that is our diene portion. So let's draw 4 of these. Well, 3 more of them. We already have 1. And as we've been doing previously, we want our large group to be on dashes. So let's draw this in as a dash. That will be our endo. Exo is going to be the wedge. We could flip this over. Endo. Exo here. So endo, exo. Because this has resonance, we can actually cross 2 of these out. So I'm going to draw the resonance for this one. If I have these 2 electrons come down, I can kick a lone pair out to here. Really, we only care about the second of these 2 resonance structures, but I'm going to draw them out just to give you an example of them. Bless you. So this would be our first resonance structure. The one we actually care about is going to be this. So we started building up negative charge down at the bottom. So on this top, I'm going to draw in a partial negative. Our carbonyl here, I can push these electrons up. Oops. To give a positive charge here. So I'm going to draw a partial positive at this position. Now, when I do my cyclization, I have a nice negative going to this positive here. And that's going to encourage this to happen. If I think about the other structure, so my other possibility would be, box this out a little bit. Where I've now flipped this over, drawing in those same partial charges. For this to happen, my negative would have to attack this position here. And because this doesn't have the charge is here, this is not going to happen. It's actually just going to select to attack this. This is going to flip over and it's going to still give you this product. So this is not going to happen. It's kind of like the reason why you think back to like Grignards, they don't ever come in. There's always this partial positive here. Your Grignard never attacks at this position. It always attacks where the positive is. Same rules apply here. This wants to attack where the positive is. There's not a positive there. That's not going to happen. So because of that, we can cross these two out. These two are not going to happen. We're only going to get these two products here. This is our endo one. Makes it our major product. And this would be the answer to this one. So they get kind of complicated. I'm going to do two more of them where I move the resonance around a little bit to give you some other examples. And we'll talk about the major product for those ones. I keep using red because it's working. Yeah, endo is generally always the major product, but there's always two endo products for these. The resonance lets you cross out like two of your four products, and then it's just down to like your endo and your exo. Endo is your major. Okay. Let's do this one. So drawing in our possible products. 6-membered ring, double bond. LME here has no stereochemistry. This one's going in, an H going out, so this will get pushed upward. Let's draw in the three other ones of these, because this isn't going to change. All right. So now drawing in all our possibilities, our endos are going to be where this ketone is going down. Exo could be pointing upward. We could flip this over, same concept. To get these two endo and exo products. This one's also endo. This one's also exo. Let's take a look at our resonance. I'm gonna do, the first one is pretty straightforward. I'm gonna do this. This is the exact same. So let's push these. We can get, oh, okay. A positive here and a negative here. So we'll get a partial positive. When I have the methyl group in this position versus on the last one, we were 1 carbon over on the top, it is going to change how the resonance works. So there's only one resonance structure with this that's possible. It's where I push these electrons down and then these gets pushed up. I can't actually get to this bond based on like normal resonance rules. There's no way for that to make a turn there. So that would give us a negative on this top position. I'm going to redraw this out for both of them just so we can kind of look at it. OME, we said partial negative up here. Partial positive down here versus this where I flipped it over, our dienophile. So thinking about our reaction, if this is building up a negative charge, if it tried to attack here, this is not where the positive is. Versus this one, we are attacking where the positive is. It's more favored. Because of that, a lot of spam today. This one is not going to happen. Our more favored one is where these two charges line up here, which means this is where this is pointing downward. So our major product, we can cross these two out, is going to be this one. All right, I'm going to do one more example. I'm going to kind of cut out some of the steps because we've talked about them previously. So if I wanted to do this faster on an exam, okay. If I think of my electrons, there's really two spots, it's either here or here for this OME. If it's at the top position, I'm going to end up with a partial at the bottom. Carbonyls always act the same. Partial positive here. Oops, this should be negative, not positive. So currently these two are misaligned, which means that my major product is going to be the flipped one. Where this carbonyl is now on the top. This got pushed outward. So OME. I can draw my endo product. Or I can flip those to wedges for my minor exit product. But most likely we want the major product because that's how we tend to do things. So that's a really quick example because I only had 2 minutes. On Monday, we will go through some more examples of these and then start on electrocyclic rearrangements. Someone asked if on the exam you'd have to put both products. I will tell you if I want the endo and the exo or if I just want the major product.